we are going to start notes on Unit 1, Lesson 4 notes. And we always start with some things to think about, because we're going to look back at our experiment and look at the evidence, and we're going to try to find and understand, hey, what's happening with our evidence? Why did I get this evidence? Why did these two pieces of tape repel, and why did these two pieces of tape attract to each other? So let's think about that, shall we? Do you remember the last time we did this? We kind of talked as a group, and we discussed things. So we're going to talk, we're going to ask questions, I'm going to answer the questions, and then I'm going to teach you some science and some chemistry along the way, okay? All right, sounds good. So let's think about this first. First of all, our goal for this investigation was trying to figure out why things are sticky. So what makes things sticky? Let's think about that. So here was our question. The first thing I want to talk about is, what is the stickiness? What is another word for stickiness? That is a little bit more science related. Does anybody know what that word is? If something is sticky? Attraction. So that word is attraction. So here's your definition of attraction. Attraction is a force. It's a pull of two or more objects. We only had two together. So it's a force. And remember, we said forces can be pushes or pulls. You could actually measure how strong that attraction was if you had a little force probe, and we do have some force probes. And when you take physics, you can put a force probe on a little car and measure how strong the force is. Okay? Now, what is our evidence for this attraction? Our evidence that we had, and the reason why we're wondering about it, is you should have had your top and bottom, and your bottom and top tape attract. Did you experience that or not? Now let's teach you some science. Why does this happen? Does anybody know the answer to that? Why do things attract? What is causing that attraction? Their charge. Charges attract. What types of charges attract? Opposites. So, opposite charges attract. And that is actually a law of the universe. That's a law of physics and chemistry. Opposite charges attract. So if you have a positive particle, it will always be attracted to a negative particle. They will always pull towards each other. And this is called attraction. Let's finish the law. Opposite charges attract. What about like charges? They repel. So they push away. So if I have a negative and a negative, they're going to push apart. And if I have a positive and a positive, they're going to push apart. Now, if you think about these little particles and their charge, let's write down the second thing we need to think about. Second thing we need to think about is what happens to the force of attraction or repulsion if you increase the distance between the particles. So let me write that down. what happens to the force of repulsion or attraction, either way there's a force, if you change the distance between them. That's our next question. Let's think about that. What evidence do we have to support this question? We always need evidence. Our evidence in this lab wasn't very quantitative, but it was definitely qualitative. Yeah.
When we charge with the rod,
yeah.
hold it to the water.
Okay.
When it was really close, it seemed to bend a lot more than when it was far away.
Okay, that's good. Charged rod, bent water stream when a rod was close to the water. Conversely, when a rod was far away, the water stream did not move. Okay, so now we need to think about why. This is our reason. Why does this happen? Does anybody know? How come the force decreases as the distance decreases? Can you tell me? There's a law, and it's called Coulomb's law. Do you know this law? Coulomb's law says that force is equal to K times Q1 times Q2 over R squared. That's Coulomb's law. You're old enough to know that now. Let's write down what all these things are. F is the force. Force is measured in newtons, if you're wondering. K is a constant. Some guy did an experiment. He put all of these things together into one number, put that on the x-axis, and then he measured the force and put that on the y-axis, and the slope of the line ended up being K. We're not going to worry about Coulomb's constant. Oops, if I could write, that would be awesome. We're just going to kind of forget about how big, it's a really crazy number. Q1 and Q2 are the size of your charge. Charges are really small. So just to tell you, this is measured in coulombs. The magnitude of a charge is called a coulomb. And just to show you how small they are, one lightning bolt has 10 coulombs in it. So if you think about that, one coulomb is really big. So if you're talking about our particles are going to be like 1 times 10 to the negative 19 coulombs. Because we're dealing on really small levels. Because you were playing with particles on tape, right? And then R is our displacement. Displacement is a distance, how far apart the particles are. So you would measure and see how far these particles are. So let's write down what happens, and you can tell just by using your math. If you increase the radius and the radius is squared, look at what happens to your force. It decreases by what? A lot. So let's write that down. If the force goes down, if the distance goes down, what happens to the force? The force goes up. I should say R. That would confuse you. If the distance goes up, then the force is going to go down. So what type of relationship is this from your math classes? Is this a direct relationship or an indirect relationship? Indirect. So you have an indirect relationship. Then what relationship does force have with charge? If your force goes up, that meant, and your displacement stayed the same, that meant your charge went up. You see what I'm saying? So when I'm playing with one of these, when I play with these, I'm holding this constant. When I'm playing with this one, I'm holding these constant, because I only want to have one variable. So notice our arrows. If our force goes down, our charge goes down. Ooh. What type of relationship is that? Direct. So that's a nice linear relationship. Okay? All right, now my next thing, any questions on that? How do we represent charge? So you had to draw a model of that, and you had to put a drawing on a piece of tape. How do you represent a charge? You're going to represent a negative charge with a minus sign. And then you're going to represent a positive charge with a plus sign. This really isn't a law, it's just kind of the way it is. The most common thing you're used to, looking at the positives and negatives, which probably was the reason why I did this. Do I have one of them in here? Is you're used to looking at a battery. Of course, when I need one, I don't have it. If you look at a battery, there's a plus and a minus on it, right? Okay. So, that's it right there. Now, is there any other questions about, we talked about how charged particles interact with each other. We talked about why. Any other questions on what you think that you want answered from your post lab? Because I can answer them right here and right now. So look through your post lab. You just turned it in. Any other questions you have that were really bothering you and you want to know what the right answer is? Yes?
Why do some particles increase force of attraction and some decrease when energy is applied?
Okay, let's write that down. Here. So you want to add that question to the driving question board. Okay. Are there any other questions that I asked on the post lab that you want to know the answers to? So you knew the answer to every single question, 100%? In the post lab? I have it right here. Any of these questions that you want me to go through? So the answer to this question right here. Yes?
Go over that one?
This question right here?
That if a particle
Okay, let's do that. So they wanted you to draw water here. So what is the structure for water? Now, you've already done this in your life. Thank you. You already have done this. You had to go back into the archives of your mind. And I was very purposeful when I gave you these cups, because I wanted you to experience this. Think about this. These are two charged particles. They have charges in them. Water has charges in it. Watch. Right now, the distance is too big, and the charge is too far apart. But look, I got it close enough, and they what? So that means that one of these is a what, and the other is a what? One's a positive and one's a negative. Do you know which one's positive and which one's negative? You don't. We don't have any evidence for that. But we do have evidence that the water molecules attract. So let's write that down. The water molecules attract, which means water has a positive part and a negative part. Now let me turn this. Notice, do these red parts attract? They don't. So that means that the red part, the oxygen, is alike. These oxygens have the same charge. Do the whites attract? They don't. So that means that the whites have the same charge. But we still don't know which part has a positive charge and which one has a negative charge. What's the other thing we don't know? So can we write that question down? Question. Which part of water is negative? Which part is positive? You had your hand up, Miles.
I did?
Yeah. You're going like this. Oh, okay. Any other questions that you want me to write down? That you're wondering about these water molecules? One part is negative, one part is positive. Think about that deeply. What's the next thing you would ask if you were 3 years old about those positives and negatives? If I just made this statement, which part is positive, which part is negative? So what we're saying essentially is there's a positive part to this water and there's a negative part to this water. What would you say as a kid? What do 3-year-olds always say? Does anybody? Yeah.
Why do the different ones attract and not the same ones?
Okay, so why do like and negative and positive? I like the first word you used. What was the first word in your question? Why? Don't 3-year-olds always say why? That's what I want you to say. Why is it a negative? Why is it a positive? Do you know why? Do you know why, where the negatives and positives are coming from in this? That is a very good answer. Do you have evidence to support your answer? That is a very possible good reason. Do you have any evidence to support that reason right now?
Just prior knowledge.
Would you like to find some evidence to support your wonderful reason?
Sure.
Okay, so let's write those questions down. Why is there a negative charge? Why is there a positive charge? Okay, and we have an idea. Let's write it down. We don't have any evidence, though. We have an idea that the positives are coming from the protons and the negatives are coming from the electrons. We have no evidence to support our reason, though. So now what are we going to have to do? We're going to have to do an experiment. And that's what our next experiment is going to be on. Where do these negative charges, where do these positive charges come from? Okay? So let's take some time and go to our driving question board and add these questions to it, please. Because we're running out of time. So open up your Chromebooks. And, so add these questions that we just wrote down. There's at least 5 of them. Brayden, do you want to put this one on there? Because this one's even deeper than the positives and negatives. We just wrote some, I had to write 4 questions down. So that group takes 1 question. You can get another one. You can get another one. Brayden's got his. Isabel, do you want the 5th one? So, and do you have any other questions that you want to put up here? Make sure they're green. Questions that have to do with the negative and positive parts of water. Put them up here. So start wondering. Wonder about water. So each person should put a question up there. And please make it green. Don't erase anybody's questions. So you guys are going to do a pre-lab tomorrow. And you might even get through the pre-lab and get to start on the lab. The lab is actually a simulation. Since we're going to be working with positive charged particles and negative charged particles, they're very small and we can't even see them in a microscope. Okay? So I have to have simulations to do that. Okay? So your next experiment's going to be all simulations. But it'll be cool. Okay, so we got why is there a positive charge? Why is there a negative charge? Let's put some of those other questions up there. We had other questions besides that. We had which part of the water is negative? Which part of the water is positive? We need to put those up there. You can be creative and think of some more questions. So I'm done with notes then.